Hello everyone, my name is Thomas Jewitt, and this is an introduction to FastAPI for PyCon US 2021. I'm going to start with a brief outline of how this talk is going to progress, starting with an overview of what FastAPI is, a little about how it works and why I'm doing this talk. Then I'm going to move into some practical examples of what a FastAPI application looks like. We'll go through some code line by line, see how an application is written, and afterwards I'll move into talking about some features that highlight FastAPI's extensibility as a framework. Finally, I will finish up by going over some of the main points of this talk during the wrap-up. So, as I said earlier, my name is Thomas Jewitt. I'm a full-stack developer based out of Dayton, Ohio. I've worked on a number of web-based projects before, both front-end and back-end, and a majority of them have incorporated Python in one way or another, typically using Django REST framework or Flask on the back-end. And so a little background about FastAPI itself. FastAPI is a Python-based framework for building REST APIs that was created in 2019 by Sebastian Ramirez, Tiangolo on GitHub. It was initially built as a way to streamline a number of issues with API development, and over time it became a very popular solution for lightweight and performant API design. So why am I doing this talk on FastAPI as opposed to any other Python web framework? Why am I doing it on FastAPI instead of Flask or Django? And for me, it really boils down to three reasons. The first reason is that FastAPI is a very batteries-included framework. It contains a lot of features that help to streamline the process of developing and documenting your API, meaning that it's a fantastic solution for rapid application development. So you may already see some interesting things on this list: automatic JSON serialization, generated documentation, easy data validation. Each of these I'm going to go into a little bit more detail over the course of this talk. The second reason is that out of a lot of the other frameworks I've used, I feel that FastAPI is one of the most Pythonic. So if you've read the Zen of Python before, you'll know that Python highlights flow, explicitness, and readability as things to strive for in design and practice. And what you'll see with a lot of FastAPI applications is that those sorts of principles will sort of flow automatically from the way that we write FastAPI functions. Sparseness, simplicity, and readability are sort of baked into the framework. And lastly, probably because of the previous 2 points, I believe that FastAPI is great for both those who are new to API development as well as advanced API developers. So I feel that even if you don't stick with FastAPI as a tool, it allows you to get a better understanding of how APIs are put together and how they can be used in practice. And so there are a couple of main factors that go into how FastAPI works. I've illustrated a couple here. On top is Starlet, which is an asynchronous server gateway interface that FastAPI uses to interface directly with the web. It uses it to become a web application, essentially. And Pydantic, which we use for some more advanced data validation and the creation of schemas that we will use in our FastAPI application. And of course, I would be remiss to mention the OpenAPI specification. This is actually one of the most important factors of FastAPI, as nearly every facet of the framework serves to build out an OpenAPI schema that can be used for documentation, portability, and generally creating a very cohesive and well-documented API. Now I'm going to step into some code examples for FastAPI to both show how the tool looks in practice and to highlight some of the points I made earlier in the introduction. I'm going to start with how every FastAPI application starts, simply by importing a FastAPI object and instantiating it. This just creates a blank application and open API schema that we'll be able to build out further with the code we write. So very briefly, this is what most FastAPI endpoints are going to look like as code. If you've ever used Flask before, this will look very familiar to you, especially with the function decorator at the top. FastAPI has taken a little bit of inspiration from Flask in this respect. But for the most part, this is just simple Python code. But there are a few features here that I want to dig into because they show up consistently within FastAPI applications. So the first one is the request method. As you can see here, circled in red. It corresponds to the HTTP request used to access this resource. So in this case, a GET request. FastAPI has support for each of the standard HTTP request methods, so GET, POST, PUT, and DELETE, as well as some of the less commonly used ones like head and options. And secondly, we have the route. This is going to show where, relative to our root URL, this resource will be located. So we also have a path parameter here, which is enclosed in the curly braces, the recipe_ID. This syntax allows FastAPI to know to use this information in the below method. And as you can see in the method itself, the recipe_ID is repeated underneath as an argument. And following that argument is the type hint to indicate the path parameter's type. In most Python programs, type hints are more of a documentation feature meant to show what type parameters are expected to be when we call a function. But we won't be the ones really calling the function as developers. That's more going to be exported out to people who aren't going to know what this entire interface looks like. So this exists not for us to call these functions, but rather to validate the data that's coming into them. In this way, FastAPI uses type hints as more of a functional tool. If we were to send a request to this route, but the recipe ID was a string rather than an integer, it would throw an error. And so that was a good example of a route with a path parameter, but what if we wanted to access a resource using something like a query string rather than having it just included within the URL path? And we can actually do this very easily by simply not including a path parameter in the initial route argument. FastAPI will detect that the recipe ID argument has no equivalence in the route, and it will determine that this needs to be included within the query string. And as you can see, both of these methods will return the same results from our data source, but the way that they are reached is different. The one on top using the path parameter and the one on the bottom using the query parameter. But both methods have the ability to use multiple path or query parameters. Now those examples showed using Python type hints for data validation, and this works well if we only have one or two variables to validate. But what if a user wants to add or update a recipe to this API? That would require validating a whole recipe object, name, description, calories, and this is actually where Pydantic comes in. So Pydantic allows us to make schemas which sort of type everything out. Every variable within a schema is associated with a type. This is an example of a schema we created to fill the role of a recipe object using Pydantic's base model class. And so, as you can see, it uses the same sort of type hints that we saw earlier in the arguments for our get functions. But now they're serving to build out a model of what a recipe is going to look like. So roughly speaking, this is comparable to something we would do in Django, where we would define models for our data. The only difference being this doesn't really require an external data store like SQLite. This is more just defining what the data should look like. The application of these schemas is actually very similar to how FastAPI used primitives for type checking before. We simply have a type hint set up for the recipe type rather than any primitive. And when we specify a function like this, FastAPI is automatically configured to check the request body for this information rather than the path or the query string. And because the query, body, and path parameters all have a unique way of being referred to within the functions themselves, you can actually safely mix these parameters within a function, and FastAPI will automatically detect where each parameter is coming from. So, for instance, here's an example of a function that will allow a user to update a recipe. It takes just two arguments, a recipe ID and a recipe object. And just from this information alone, FastAPI knows to interpret the recipe ID as a query parameter and the recipe object as a body parameter. FastAPI also gives us tools to validate these parameters using more than just Python type hints. So for each of the parameter types that we talked about, FastAPI also includes a dedicated class to represent these parameters. This example shows using the query class for a query parameter to further validate one of our get methods. In this case, we want to ensure that the user isn't entering a number less than 1, so we specify the default for the recipe ID argument to be a query parameter that is greater than 1. If you try and access this resource with a recipe ID that's, say, -1, this will also throw an error. And so this is the Swagger UI that was created when we first instantiated our FastAPI app. You can see each of the endpoints that I talked about listed underneath. And this documentation was sort of generated in the background just from defining those methods earlier. This interface not only shows the endpoints and schemas that we've defined, but also allows developers to run tests on each of these functions to make sure that they're working properly. Now, this is good on its own, but this is just what we've generated with the code that's already been written. What if we wanted to document this API further? And we're going to look at the functionality that allows us to do that. Each FastAPI method can have arguments entered into their decorator function to further document each endpoint. So in this example, I've changed the summary of the endpoint and added a description to it to be displayed in the documentation page. This is actually just inserting the metadata straight into the OpenAPI schema that we've been building. So any documentation entered here will persist in the application itself, regardless of if we export the schema elsewhere. And as you can see, when we go back into the OpenAPI docs, when we expand this endpoint in particular, the extra documentation that we just entered is now included for this endpoint. And this process can be repeated for other parts of FastAPI. The FastAPI object itself can receive arguments such as title and description, and those will be seen at the top of the interactive documentation when you save the source code for it. As you can see there, we've got example recipe API. Now I'm going to step into some features of FastAPI that, while not going to be used in every case, are still useful enough to API developers that they warrant mentioning. And I'm going to start with some different response types. The examples you've already seen were functions that returned Python dictionaries, and FastAPI was automatically serializing those dictionaries to JSON. But FastAPI also includes a number of classes that allow us to create responses in other formats. This is an example of a function using an HTML response as opposed to a JSON response. The class that allows for the different response type is entered in through the decorator function, like how the documentation from before was entered. This allows us to serve our alternative response class as opposed to the default JSON response class. When a user visits this route in our app, the data will be in HTML. FastAPI has a support for a number of other response types, which allow your application to enable streaming binary data, serve files to users, and even standard web pages. It also includes an extendable response class, which allows you to customize the format of the data that you're sending. So for instance, if you have a legacy API that you need to maintain and you want to send your data in XML rather than JSON, you can extend out the response class to provide that data. So FastAPI also has built-in WebSocket support for two-way communication between clients and servers. The way we would declare a WebSocket is actually very similar to the way that we would declare an HTTP endpoint, simply creating a function using the WebSocket decorator and passing in a WebSocket object as its only argument. This enables real-time data to be sent between the client and the server, enabling features like push notifications or events to be sent to the client. So I'd also like to mention some very useful third-party tools that are available to augment FastAPI's functionality. So first, the FastAPI code generator. This greatly enhances the OpenAPI aspect of FastAPI, as it allows you to take any OpenAPI schema and generate an entire project from it, including endpoints, object schemas, and documentation. Pydantic SQL Alchemy. Now this one is less third-party than the others because it is also developed by Sebastian Ramirez, but I feel that it's useful enough that it warrants putting here. This library allows you to create Pydantic models straight from SQL Alchemy models. If you're using a SQL database for your data store, this makes the process of using FastAPI to represent those resources much, much easier. FastAPI pagination, and the closest thing to compare this one to is Django REST framework style pagination, where you would have pagination classes and a number of results to limit from each JSON response. And this can become very useful if you have a very large data store with a large number of objects that you are going to be serving to the user, as it limits the amount of resources going to be used by your server at any one time. And finally, I want to mention Awesome FastAPI, which is a list of third-party tools and resources curated by Michael Herman on GitHub, on which you can find the source for many of these, including the three above. And now I'd like to wrap up by going over some of the key points of the talk. This talk tried to cover a lot of ground, but there are a few important things that are worth restating here. The first is that FastAPI is built on OpenAPI, Starlet, and Pydantic. Each of these tools are very lightweight and provide features necessary for FastAPI to create APIs quickly and easily. Secondly, the features of OpenAPI allow the use of built-in documentation. The features of Pydantic allow for easy data validation when sending JSON to the API. And FastAPI itself serializes and outputs JSON from standard Python dictionaries. All of these advantages add up to FastAPI being a very performant, Pythonic, and accessible framework. FastAPI allows developers to do previously very complicated tasks very quickly because of this. FastAPI uses the type hints introduced in Python 3.6 in order to perform simple data validation on parameters used by the API, and this allows us to easily and reliably validate data with a very low code footprint compared to alternate methods. These type hints are also used within Pydantic schemas, allowing us to validate JSON objects supplied through POST requests to our API. This also creates a schema definition within OpenAPI, allowing us to document more information on our application. And since FastAPI handles each type of parameter in a different way, every parameter type can be freely mixed together without needing to add any extra code to ensure compatibility. And since all of this information is automatically inserted by FastAPI into the OpenAPI schema, interactive documentation can be generated just from the code we write. We can also add manual documentation to the API, each endpoint, and each schema that we build. FastAPI has many response classes that allow us to customize the type of API we want to build or design, and allows serving files, streaming data, and HTML, stuff that isn't typically included within an API, but FastAPI has the flexibility to provide us. FastAPI also allows us to use WebSockets, enabling real-time two-way communication between the client and server. And FastAPI also has a great amount of developer support behind it in the form of third-party libraries that exist to enhance its functionality. So in conclusion, FastAPI leverages the features of Python to create fast, intuitive APIs with very little code needed. This in turn makes FastAPI a great choice for projects that incorporate rapid application development, as it minimizes the time needed to create a viable application. I hope that I've done a good job of explaining what FastAPI's benefits are, how it can be used to build out applications, and how to start coding with it. And the rest is up to you. So, thanks to everybody that made this possible. I'd like to give a special thanks to the Python Software Foundation, Sebastian Ramirez for creating FastAPI, FastAPI contributors for contributing to FastAPI, Michael Herman for curating the list on third-party FastAPI libraries, and you for attending this talk. Have a great con, everybody.